Superposition is a frequently used circuit analysis technique that aims to simplify the calculation process of complex circuits. While simple circuits enjoy the direct application of Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law independently, the superposition theorem combines these principles into its methodology in order to reveal the unknown voltages and currents of a circuit. More formally, the superposition theorem states the current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced by each source, or more simply, the sum of multiple voltage and current sources equals the sum of individual sources in a simplified circuit. You might want to write that one down. The method for superposition can be broken down into 4 steps. 1. Select. Select either a voltage or current source as a point of reference. 2. Remove and replace. Remove all other sources by replacing voltage sources with short circuits and replacing current sources with open circuits before determining unknown voltages and current. 3. Repeat. Repeat step 2 for all other sources. 4. Sum. Add resultant voltages and currents to determine the unknown. Let's apply these steps to an example. Example 1 shows a circuit diagram whereby we have to find the value of I2 using superposition. Applying the 4 steps yields the following solution. 1. For this example, we can select either the current or voltage source to be the first point of reference. I chose the voltage source first. 2. Replace the current source with an open circuit and determine the unknowns. It helps to draw a diagram. Apply Ohm's law to determine I prime, where I prime equals the source voltage divided by the total resistance, which is 18 divided by 6 plus 3, which equals 2 amps. 3. Repeat step 2 for the current source by replacing the voltage source with a short circuit and calculate the unknowns, whereby I double prime equals the current source times by the total resistance divided by resistor 2. That is 4.5 times 2 divided by 3, which equals 3 amps. 4. Sum the values of I, where I2 equals I prime plus I double prime, which is 3 plus 2, which equals 5. And that's the solution for example 1. Here's another example. Pause the video and solve for I2 exactly as we did in the previous example. The solution will be posted after. An important note, while superposition is very useful for complicated circuits, it is limited in its application as it can only be applied to linear circuits. That's all for today. If you would like to have a crack at more difficult superposition questions, please feel free to refer to the ENGG104 textbook. Thank you for watching.